So I have watched this video documentary of how Instagram has migrated from Python 2 to Python 3, and the idea of making this video came from this sentence.
Instagram has been running fully on Python 3 for a few months.
The whole process took, I would say, about 9 to 10 months. And I think Instagram is the largest production deployment for Python at the time.
She gave a very good, very thorough talk explaining why
What's
they
this?
did it,
Two main things, typing and async I/O.
how they did it,
We cleaned out all the libraries that are not making
Hold on.
the migration from Python 2 to 3.
how you should do it,
Unit test.
what they had learned
Exactly.
during the process.
So this is actually a great statement, but in fact, Instagram had spent 2 months to write unit tests before starting the migration. Imagine if they actually had those tests from the beginning and they were just starting migrating from the first sprint. And that's actually the thing, having unit tests written from the beginning while you are developing a feature pays off later when you, for example, want to migrate Python 2 to Python 3 in a big scale product. But you see, there is still a problem. When I first started working as a software engineer, there was this idea of having a new product where we should have 80% at least test coverage, but nobody was impressed about that. So the question of this video is, what exactly 80% test coverage means and when is actually this information relevant? Let's dive into that. So I have this little project here where we have a calculator where it just adds and subtracts 2 methods, simple as that. Then we also have a number checker where it just has a method to verify if the number is bigger than 10. And then we have this string processor where it processes an input. And then if the input has more than 10 characters, then it just adds this text into it. If the input starts with Y, then it just says, and it was probably a question. And then if the string contains a secret, then it just returns an optional of empty, meaning that it doesn't return the actual text. Or if it doesn't contain, then it returns the input. And then we have all those tests here for those 3 classes, where the first one just tests the add method, the other one tests the subtract method, but there is actually a problem here. And I want to deep dive first into this calculator test. So as you can see here, we are using the add method, we are testing it, the same for the subtract, but we are actually not testing the actual output. And if we go here inside this one, and then we want to run the calculator test with coverage to see how much test coverage we have on this calculator class, you'll see an interesting thing. As you can see here, everything was 100% covered. So that means that we can just go on and, for example, develop a new feature, because now for this calculator test, we have everything done. But in reality, we don't have an assertion. We don't know exactly what was added or what was subtracted. And the same thing goes for the next one, number checker test, where we are testing 2 use cases of the is bigger than 10 method. But again, it shows us that this number checker class has 100% test coverage, because again, we are not asserting the result after calling this method. And again, as a last one, we also have it for the string processor, where we have 4 tests created. The first one just says that this input is present, which is fine. But for example, the next one, where it tests the long string, and that one has more than 10 characters, we know that it should actually add this specific string to it, this specific text, which is this had more than 10 characters. If we go back here, we don't have any assertion for it. So again, it's a false coverage. The same thing goes for this one, test question string, where we just asserted again that this is present, but again, we are not asserting that actually it has included that question into the text. So if we go back here, it should actually include this, and it was probably a question. And for the last one, test secret string, we don't have to assert anything else. We just want to know that this is actually empty. So for this specific test class, we are only looking on those 2 tests that are not actually covering the specific use cases. So how we actually do it, how we actually know that this information is relevant. So one of the things that we actually have to do is to include those assertions that I was talking in the beginning. If we go back inside the calculator test, we have to add an assertion that after using the add method, the result is actually 5 in this case. But before diving into how we can do it so the information is relevant, I want to run this method, which will show us a report with JaCoCo plugin on the test that we have created. And we can see here that everything is 100% test coverage. We can see that we haven't missed anything inside that. So we are good to go in this case. Everything is done. But if we actually go inside the test again, after we have created the JaCoCo report, now I have another plugin, which is the PIT, which will add mutations to the test. So what it actually does, I'll just run it because that's the first thing that we have to do. Then we'll just open it. And then as you can see here, we have mutation coverage, and 2 out of 13 from all tests inside our project failed. So that means that we still have to do some assertions. So all those 13 are actually green. And what does it mean inside the calculator test if we go back? That means that if we, for example, will just now create the assertion for this one and say that this should be 5 expected after we run the add method, and the same for this one, this should be 2. Then if we run it again and if we just open it again, we can see that now we have 6 out of 13 that are green. So mutation in general means that our add method, the PIT test coverage, will just go inside our code, will change, as for example, inside the calculator, the a plus b to a minus b on the add method, and the test will not cover that because we don't have assertion. So it will just report it inside the index.html that this one has failed when he has added the a minus b instead of a plus b on the add function. Now, because we have added the assertion inside the calculator test and we say that this should be 5 expected after we run the add method, then that means that our PIT test now has 6 out of 13. And one of the interesting things that we can also see with this PyTest plugin is that we also have a comp.demo where we have a report per each test class that we have in our report. So if you go inside the calculator and open it, we can see that he has tried to change from a plus b to a minus b, and that one was actually covered. If we go back inside the project and run it again for the number checker, this one we still don't have assertions. So we can see that he has tried to change the if statement, he has tried to remove the conditional, and both of them survived. And he has also tried to replace the boolean return with false or true, and also those have survived. So that's why for this one, we still, if we go back inside the whole report, we can still see that those were not actually green, they're actually red. So we'll just change it again. So for the number checker test, and do the same thing. Actually, I can just say assert true and assert false and run it again, and we'll just open it again. Now we can see that 3 of them were killed, but still 1 of them has survived. And if we go back to the whole test coverage of the PIT test, now we can see that we have 9 out of 13 covered as a mutation coverage. So with that, in my opinion, test coverage is just a flawless statement when it is not covered by what was actually tested and how it was tested. And of course, that can go in many directions depending on your scope of the project, on your features that we have in your project, or on your tech stack. But things will always remain the same when we actually talk about unit testing. I would really like to know more about your test coverage experience. And until then, thanks for watching and see you in the next video.